Assalamu alaikum wa rahmatullahi wa barakatuh. I'm going to give you an introduction to the SAP Online Analytical Processing and the data warehouse, where the data store before you actually start the, the exercise in Business Explorer. So you all have taken databases, and you know that a database stores data in two dimensions. That's the table. The table has two dimensions. You have the columns and the rows. However, when organizations try to do decision making, they need to integrate data from different sources. So sales data with manufacturing data, with customer data. A lot of data need to be integrated together in order to make a sound decision. So you need large quantities of data from different functional areas. So you take the relational database from these functional areas and you put them in what we call a data warehouse. Of course, before you actually put them, if you put them all together without cleaning the data, without what we call staging the data, meaning make them consistent and that there is no inconsistency, maintain the consistency between the data, then if you do not do that, if you do not stage the data, then you will not be able to connect or make sense of the data inside of the data warehouse. Now, in a relational database, if you have taken database course, you know that you have to normalize the tables. And the reason you normalize the tables is because of the anomalies. You are afraid that if you add a particular record, that it may disrupt the consistency between the tables, or if you delete one thing, then you will not be able to access the rest of the information. So we have data anomalies that we are afraid of in case of a database. Now, we said the data warehouse, the reason that you would create a data warehouse is for analysis, for supporting decision making. So this is not a store for actually supporting daily transactions. You do not store records as they are entered in the data warehouse. You accumulate the records in a database. So there is a database where every record that is being transacted or every transaction that is submitted is stored inside of the database. End of the day, sometimes end of the week, end of a quarter, you take all of that data and put it inside of the data warehouse. So the data warehouse is only for data analysis, and thus the data is read only. It is considered historical data. You do not change it. And therefore, there are no anomalies. You are not afraid of any of the modification anomalies. You will see that, and that's why we say that the data warehouse is denormalized. We do not normalize tables in case of a data warehouse. We need the normalization in a regular database because we are afraid of the anomalies, which happen when you either add a record, or you delete a record, or you make change to the record. Now, all three things are not possible in a data warehouse because we said this is only historical data. So you are not going to make changes, you are not going to delete, you are not going to add a new record. You add in the database and then you take to the data warehouse. And that's why we say that a data warehouse is a single source of truth. Now, we mentioned that an ERP system, for example, has one version of the truth because we have a central database, all of the different functional areas, they store in that database. In a data warehouse, we said we combine different sources of information into the warehouse. So all information that is needed for decision making reside in that data warehouse, and that's why we have that single source of truth. Okay, so the relational database is a transactional system, meaning it supports the daily business transactions. Like what? Like buying products, like selling to customers, like manufacturing, like managing human resources. An employee does not appear today, so it is reported in the system either as a sick leave or absence. All of these are like transactions. Someone submit for a vacation leave. An employee is sent to training. So like in the different functional areas, you have different business processes that you perform on a daily basis. The transactions, the records for these business processes are stored in a relational database that is normalized, as we said. Now, in a data warehouse, we combine different sources of information, different databases into one data store. And that store is just to support, as we said, analytics, data analysis. And thus, it is called an informational system. It is a system to provide you information that support decision making. The question that I would like you to research is, can we combine the two data structures? And we said that, for example, a data warehouse is a read-only, whereas the relational database, you can write. What happened when we combine these two data structures together? What happened to the performance? So I will actually listen to your comments when I come back on Monday. I think it will be November the 7th. Now we'll talk about the process of creating a data warehouse. First step is that we need to identify the sources of information. Where is the data that we are interested in? Where are the databases? What databases do we need to extract data from, get the data out from? Of course, sometimes it is purging, meaning getting them out and copying them, taking them into the data warehouse. In other times, just like taking a copy of the data. So we have to identify the sources of information. And when we do that, you find a lot of inconsistency across the sources. There is a lot of inconsistencies across the sources. Why? Because they have different format, they have different style, there may be redundancy, repetition, there may be a name, something that is named one thing in one source and named differently, but it is the same in a different source, like client and customer. They're basically pointing to the same thing, a customer. But in one table or in one data source, it's called client, and in another data source, it is called customer. Sometimes the column may be named the same, like unit of measure, and unit of measure. And then you look at the data, and in one, it is a certain unit of measure, like volume, it's measuring volume, and in another, it's measuring kilograms, and you should not be combining the two. So all of these inconsistencies need to be resolved before you actually store the data into the data warehouse. And we call that cleaning, data staging. The data staging. In the data staging, as we said, you're trying to remove all of the inconsistencies, make sure that you don't have missing data. So there is a lot of the cleaning of the data. And they say that's the most expensive step, that a lot of effort is currently being dedicated or allocated to data staging. And then when the data is ready, then it is, it is stored inside what we call an info cube or a cube. So that you can run the analytical or use the analytical tools to generate reports and support decision making. That whole process is called ETL, and the E stands for extract, T transform, L load. So you have to extract the data from the data sources. You have to transform the data. The staging, as we said, there are lots of inconsistencies, and you are trying to resolve the inconsistencies. And at the end, you have one format for the data. Think about, I'll give you a very simple example. If I have some data in Word, some data in PowerPoint, some data in Excel, there is no way that you can run analysis with all these three different data formats at least for the file. So you have to decide on a standard form, let's say Excel, and we say all the data from Word and all the data from Excel will have from PowerPoint will be transformed into Excel. In that transformation, you see maybe there is a lot of redundancy. The data reside in Word and also in PowerPoint. There is, as we said, something that is different but it's pointing to the same thing. Or two things that look as if they are similar, but they are actually pointing to different things. Like I told you, the unit of measure. Excuse me. So all of these inconsistencies need to be resolved, and that's what we call the transformation stage. And we transform everything into one standard format. Now the data is ready to be stored into an info cube. So we are loading the data into an info cube so that we can run the analysis on it. So, as we said, we have the different source systems. These are your different sources for the data, different applications. You're taking that data and doing data staging. That's the cleaning phase, where you remove all of the inconsistencies and resolve them and remove repetition. And then you go into the data warehouse. It's ready to be stored. But the data warehouse becomes like a huge store of information. Different groups within the organization will need different pieces of information. So you may, no one group will use everything unless they are the executives at the very top that need to look at everything. But majority of the users, the knowledge users within the organization will require a piece of the information. So we build for them what we call data marts, which are a mini model of the data warehouse. And then you run analytical tools on the data mart. Okay. Now let's look at the data inside of a data mart. What does it look like? Now you all have seen like a relational database, the data model for a relational database. The ERDs, the entity relationship diagram that shows the different tables that are connected. Here we have a fact table. The model here is called a star schema, by the way, where you have in the middle a fact table that is connected to different what we call dimension tables. So what's in the middle? A fact table is capturing something that is important for the organization, a key performance indicator, if you have heard the term before, KPI, which is, as we said, it is a figure or a key figure that it is important for the organization to monitor and to track and to follow up on to make sure that they are reaching the objective for them. If I ask you what would be what would be a key figure, sales would be a key figure, revenue would be a key figure. Now you can show information about the fact table using one or more of these dimensions. So I can show, for example, the revenue by customer. I can show the revenue by region. I can show the revenue by sales organization, which means, like for simplicity, like a store, a specific store, for example. A region would include multiple sales organizations, for example. You can show revenue by time. Like, how did I do in the third quarter compared to the last quarter of last year? You can show revenue by product. So we have a fact table, and that fact table is a key figure that is important for the organization to track and to monitor and to follow up on. That fact table has a number of dimensions, or connected to a number of dimensions, that are used to present information about the fact table. So, as we said, revenue can be viewed in terms of customers, or in terms of time, or in terms of a specific region, and so on. So as you can see, the revenue, every product, can generate multiple revenues in multiple periods. The periods, let's say, are days, specific days of a month. And a store, again, will have multiple revenue sources. A particular period, like in a particular day, again, I'll generate revenue from multiple products, multiple stores, and so on. SAP has a slight naming difference from that star schema. So when we say a fact, like a key figure, as I said, SAP actually says it's a key figure. They don't say a key performance indicator, but they call it a key figure, which is, as we said, an important value that the organization track, because it is tied to its strategic performance. However, when they call the table, they call the table a fact table. So a key figure is stored inside of the fact table. The dimensions are the different characteristics or attributes that can present information about the key figure. As we said, every dimension has a group of characteristics. So if we say, going back, for example, a product has a product ID, a product name, a product color, a category, so number of characteristics tied together, and now we call them a dimension. So, I know you will have not, or I think like majority of you have not taken the ERP course, but in there we have something called transactional data and master data. Master data is data that does not change from one cycle, from one business cycle to the next. Example would be customers or suppliers or products. All of these continue to exist within the database from one business cycle, 1 year to the next. The fact table is a transactional table or transactional data that is generated because of the daily transaction. So when you sell, you have revenue, you have sales. So that transaction data is stored inside of the fact table. A dimension table, as we said, I mean, like it is the same like master data, but I mean, technically they say it is actually the link between the master data and the fact table. If you know the associative entity in relational database, that would be a dimension table. Why? Because in a relational database, a customer has the information stored in a customer table is just the customer the information, their ID, their name, their address, and so on. But then in a dimensional table, you have a customer information along with all the invoices. For example, a customer have placed. So it's a combination of actually a master data and a relational data. The master data, the part of the master data is the customer ID, the customer name, the address, and so on. However, the transactional data is the invoices that the customer submitted. So, and that's why they call it the dimension table. It's the link between the master table and the fact table. It has information from both. All of these now are stored inside of the info cube. So the cube has master data, has fact table, has dimension table. The master data is data that does not change. It has part of the dimensional data, so it represents customers, suppliers, material. And they're saying you can use it in multiple fact tables. So if the key figure that I'm tracing is revenue, customer of course will be connected to it. But if the key figure is something is different, can you think, for example, how can customer, what would be another key figure that would be connected to customer? Well, we have customer satisfaction. Customer satisfaction, even though sometimes it's not quantitative, it is qualitative, but majority of the companies will actually transform that qualitative into quantitative. So satisfaction is measured on a scale of 1 to 10. And based on that scale, you say whether, or you determine whether customers are satisfied or not. So satisfaction is a key figure. It is an important aspect for organizations to track and to monitor and to follow up on. And it is tied to a master data, which is the customer. So the master data can be tied to multiple key figures. The master data is designed to support multilingual systems, which means that the information about the customer can be presented either in Arabic or in English. It supports time-dependent data, which means that it can show changes based on time. And of course, I mean, like, it is designed so that you can run queries on. So as we said, a dimension is a group of characteristics that belong to the same object. As we say, a customer has a customer ID, a customer name. So they are attributes of either of the master data. Some of these attributes, we call them navigational attributes. Navigational attributes. The navigation attributes are information or data that reside in the master object. So it can be like address, zip code, and so on. So you may want to find out how many customers do you have in a particular zip code. The navigational attributes, as we said, are characteristics that reside in a master data. And we said that the master data is like customers, suppliers, so it's an attribute of that is permanent, that permanently exists. Now, the time-dependent attributes are attributes that may change over time, like a price, like the pay rate for an employee. The time-independent are attributes that their value does not change. So a product weight, its volume, it will continue to be the exact same thing. So here you see that the fact table has revenue, which is a key field, key figure, and you can display that with a currency, or like if you are looking at sales quantity, you can have a unit of measure. And now to define the currencies, you have another table that tells you the key for the currency and what it stands for, the description of it. Same thing, the kg, the unit measure, the code for every unit measure and its description. Now, so the facts and the dimension connected to the fact table reside inside of the info cube. The info cube is multidimensional. And if you remember from pivot table, we said that multidimensional meaning like it is several tables stacked on top of each other. Now, the multidimensional model allow you to generate very complex reports and to do complex analysis. Even though we just like used OLAP up until now, but you will see how you can run statistics and get sophisticated results from the info cube. Okay, and of course, like same thing like you would do in a database, you run queries, you can also run queries on an info cube. Now here is the GBI model, data model. We have fact tables in the middle that has the sales quantity, revenue, discount, net sales, cost of goods. Each of these key figures can be presented either as from a customer perspective, from a time perspective, from a product perspective, from a unit perspective, from a record, a particular transaction. And that's all for the intro. And then now Hania will let you start the exercise. Thank you very much.